Hello, hey Christian, how you doing?
Hello, I'm fine, thank you. How are you?
Fine. I'm all right. It's nice and almost wintry here in Seattle. So
It's
if you,
almost it's almost quite wintry here as well, so
yeah,
really cool.
it's getting like the holiday season is starting up, so it's getting colder. Hopefully, we'll get some snow as well. But anyway, if you're here, say hi in the comments. What we'll be doing today, this is episode number 61, and we'll be exploring OpenTelemetry today with Krisztian Fekete. He's a field engineer at Solo, and he'll give us I would say, a 101 overview of OpenTelemetry. I'm I don't know nothing about OpenTelemetry, so I'll be listening and asking questions if no one else is going to have questions. But definitely looking forward to learn about OpenTelemetry, what it is, how it works, I guess, and then how to set it up with Istio. So I'll hand it off to you, Christian. Go ahead and
All right.
let's
So
talk about OpenTelemetry.
exactly. So hello everyone, and Peter, thank you for having me. We were talking about OpenTelemetry. It won't be an extremely formal session. I have a few slides because I was presenting a topic on OpenTelemetry at SRECon in Dublin in last month. And I think we can reuse some of those slides and graphics that I created for that conference, because defining what OTel OpenTelemetry is might not be as straightforward as it should be or is currently, because it's kind of an umbrella term and that has lots of moving pieces, and depending on what type of background the actual people have who are talking with you about OpenTelemetry might think of another kind of OpenTelemetry that you are referring to in the conversation. So it can be quite challenging to. There are some funny conversations when someone says that, okay, we have to be compatible with OTel. We will do this with OTel, and depending on who you are talking to, the other person might be referring to a completely different tool in the OpenTelemetry ecosystem. So these slides, I have a few slides. I think it's like 10 or maybe not even 10. We will go through those, and I will try to show you where I think most of the confusion is coming from. And after that, I have some graphics, and we will go through some architecture diagrams. We will see some actual practical examples of what an OpenTelemetry configuration could look like. If we are talking about OpenTelemetry collector, that's one of the OTels out there, and at the end there will be a small demo of how you can use OpenTelemetry and Istio and what kind of features you can get with that. So yes, that's the high level agenda for today, I think.
Yeah. So OpenTelemetry is not like, and forgive me for like stupid questions, right? Because I'm not
There are no
familiar
stupid
with it.
questions.
Yeah, I know everyone says that, but
Yeah,
this one
but
is.
still, the first time when OpenTelemetry came out, I checked the documentation. I think in the last, I don't know, month two after it just came out, and that was the most confusing piece of documentation that I've ever seen. I think it was just not great, and there are still areas to improve, but it got a lot better recently. It's getting more and more popular. There are stats when people say that it's the second most active and most popular project in CNCF and things like that. And it shows there are lots of contributors. They are also working on the documentations. The tooling is getting better. It's getting better, but yeah, I will. Yeah, it's not easy to get it right if you try to do this many things that OpenTelemetry tries to do.
Oh, okay. So it's like when I hear OpenTelemetry, the thing that comes to my mind is, oh, it's like an SDK that I include in my code to
Exactly.
do metrics, I guess.
Exactly. That's a valid definition. But if you are talking with someone else, they might think of the collector or the OpenTelemetry operator.
Okay. So there are multiple pieces. It's like a high level term, OpenTelemetry, that includes multiple things.
Lots of things. For example, if you are talking to a third person and you say OpenTelemetry, they might be thinking about the schema or the protocol. So it's not just two things, because that would make it's still confusing, but it's simpler. But it can be, I don't know, 7 things.
Okay. So is it fair to say it's like almost like like a term whenever we say like service? It's like, okay, what do you mean by service? Is it Kubernetes service? Is it service as an application? Is like
or
same
application workload? Workload is another
or workload. Yeah. It's almost like an overloaded term that can mean a lot of things for different people, I guess.
Yes, but it's even worse, I think, because if you say workload, you cannot really expect that the other person will also think of the same workload that you are talking about. But if you are using a technology or a term like OpenTelemetry, if you don't have this problem with Kubernetes, if you say Kubernetes, everyone more or less knows what you are talking about. There are several differences there. I don't know, that can be a kind cluster, EKS cluster, AKS cluster. It can be multiple different versions of Kubernetes. But in general, everyone is know that what that thing's supposed to do. But that's not true for OpenTelemetry.
Okay. Well, interesting. Let's see. Let's learn. I'm curious to unpack all this.
Okay, great. So I will just share my screen. I think it should be shared. Okay. And at the beginning, just let's go over these slides. It's like 12 slides, and I try to be quick. I had this in a presentation. The talk was actually 35 minutes, I think. 35 minutes, and I had more than 50 slides, and this is only 12. So we should be able to go through this quite quickly. So this actual presentation was about 2 topics. One of them was coming from my frustration on the same topic that we were just discussing. You might not referring to the same OpenTelemetry that the other person is referring to, and these discussions can be confusing. So I try to create some graphics and some slides to make it easier to understand where is the confusion coming from and how to articulate this properly. That was the first part of the presentation, and the second part was about several use cases where it might make sense to use OpenTelemetry and the collector in particular, because my talk was mainly focusing on the collector. So it's very likely that there were some people who attended my talk and they were expecting something else, because OpenTelemetry was in the title, and who knows, maybe they were also expecting something about the SDKs or something like that. So, as we already mentioned, everyone is talking about OpenTelemetry. It's getting more and more popular. You can see this graph here, seeing how it got more and more popular over the years. But this is from Google Trends, and I use this to show how the interest was raising. But if you are using Google Trends and you scroll down, then you will see you can get some additional insights. For example, the related queries. And if you take a look at this, you will see that you will see one of the reasons why people are talking about different OpenTelemetry when they are talking about OpenTelemetry, because the first result is collector. We can say that based on that's the most popular OpenTelemetry out there. But then we have OpenTelemetry Java, then Jaeger OpenTelemetry, then Jaeger in itself, then Prometheus OpenTelemetry. So it's quite confusing, because you might not know which one you actually need to search for to find some additional information. OpenTelemetry Java is basically one of the SDKs or libraries that you can use to, as you said, to instrument applications to emit some kind of telemetry data. That can be logs, metrics, or traces. But yeah, there's also the collector. So what people can do is that they can go to the website OpenTelemetry.io and try to see what's the official definition. And the official definition is this. And I'm not sure what was the official definition when I first checked the docs page, but I'm not sure this is better, or I don't know. What do you think of this definition?
I actually like I'm a very practical person, but I always was like, oh, I don't care about theory that much. Let me see it in practice. But then in like as I got older, as I got older, I guess like I do prefer definitions. But let me read this. So OpenTelemetry is an observability framework. Okay, so it's a framework. I don't know what observability framework is necessarily. And a toolkit.
Okay, so see, you try to stop at framework, but then you continued and toolkit. So
so it's designed to create and manage telemetry data. Okay, so telemetry data is then traces, metrics, and logs. Okay, so crucially, OpenTelemetry is vendor and tool agnostic. So that tells me it's like an well-defined interface that everyone agrees upon, right? And it can be used with a broad variety of observability backends. I don't know what observability backend is necessarily, including open source tools like Jaeger and Prometheus. Okay, so Jaeger and Prometheus is probably an observability backend, and commercial offerings. Okay, so they're commercial offerings, and it's CNCF project. Okay, yeah, it's a lot of things.
Is it better now? So.
I mean, it still doesn't tell. It tells me at least that it's a collection of things.
Things, exactly.
For creating and managing traces, metrics, and logs, and it tells me that there might be like a same interface that I can use regardless of what the backend is.
Yes, and you can even use it for commercial offerings. So that's something that sounds exciting. It can be interesting to some people, but you have to read through all the other lines before that. And you might lose people there because this is a lot. I just tried to read this on my screen, and I actually had this slide at the conference. It was a big screen, but if people, I don't know. It's just it's hard to define it like this or anyway. But
with like one sentence, right?
Exactly. So I use these AI generated graphics to illustrate my frustration, but it's nice. It's better than emojis and GIFs, maybe, or maybe not. Who knows? So if you continue to scroll down on the site OpenTelemetry.io, then you will find this. And this is the last, I think, when people will get lost. So OpenTelemetry consists of the following major components: a specification, protocol, semantic conventions, APIs, library ecosystem. There's automatic instrumentation. Where is that coming from? Then you have language SDKs. Then finally, lastly, you have the OpenTelemetry collector, which is a proxy. Well, what kind of proxy? Receives, processes, exports telemetry data. So I'm not sure that this will make it easier to if you just go through the major components, right?
Yeah. It's still like, it feels like one of those things where you look at the top and then you start digging in and it's even more, always more stuff. And then
you just close the tab, right?
Yeah, exactly. Like it feels like each one of these is like, oh, I have to research. Okay, so it's a specification for all components. I don't know what the components are. Standard protocol, okay, defines the shape. Okay, semantic convention.
But let's take a look at this from an actual end user perspective. Let's say you are a developer who wants to add OTel into the application, and you will see something like this: specification and protocol. These might not be the first thing that you are interested in if you want to add some instrumentation. If you are an ops person, then it's more likely that you are not interested in these, and you will just be confused. Okay, this is an open standard, but it is standard protocols. It's another protocol. Is it HTTP? Is it gRPC? What is it?
Yeah.
So it might not make it easier to.
This guy is so frustrated. He has a third hand.
Exactly. And this is, This is why I like to illustrate, especially if you want to illustrate something in a presentation. It's quite nice to use these AI generated images because I was I forgot to include the prompt here, but I was not. I think I didn't have the phrase frustrated or frustration itself. You just type something inside, and maybe I had some frustration in the prompt, but that hand on the keyboard.
It's
Interesting.
I just noticed it, but yeah, makes sense. Makes sense. Yeah, Marino is saying feels like this person has 3 right hands. Well,
That's also a possibility.
it's better to have 3 right hands than 3 left hands, right? Or whatever the saying is, right?
Exactly. But the computer screen is quite clean. You don't even have the OpenTelemetry
Yeah,
definition
there's
up
nothing
there.
there.
So and the same is being reflected on the glasses. I don't know.
Yeah.
It's a nice image. I really like this. I think I will save this one and use this at other talks and presentations as well. So we were talking about OpenTelemetry being a standard. So that's the corresponding XKCD comic that can pop into mind. So the situation is there are 14 competing standards. So some people try to solve this by implementing a universal standard that will cover all the use cases. So the situation afterwards is that there are 15, so plus 1 competing standards. But yeah, in the defense of everyone who is working with or contributing to OpenTelemetry, it's quite hard to come up with a good definition and a good standard if you want to do all these kind of things. If you want to be the Swiss Army knife of, I don't know, OpenTelemetry, then you will have challenges if you want to get people abroad. But apparently that's not that much of an issue, because there are some people who are thinking of this comic when they are talking about OpenTelemetry, but it's really popular, and there are some good use cases for OpenTelemetry for sure. So I think it's not too bad. I was hesitant to include this slide, but I decided to include it anyway. Why not? It keeps people engaged.
Yeah, it also describes the complexity, right, in a way.
Exactly,
Right,
exactly.
yeah.
So it's a hard job to work on and work with OpenTelemetry to some extent, but I think there are some use cases where it's actually variable. You can go to the SREcon website and search for my talk. The video is already up. I forgot to send the slides to organizers, so apologies for that. But if you go to my blog, krisztianfekete.org, you have all the slides there with the presenter notes. So that's, if you don't want to watch the whole thing, that might be also a good option. And I will send these slides to the organizers as well, because I promised to. Okay, so this is my own take and definition or explanation of the official definition. So basically, whatever OpenTelemetry is, there's a framework, and you can use the former one, the framework, to instrument applications to emit some kind of observability data, telemetry data, and you can use the latter, the toolkit, for example, if you want to simplify it. And we won't talk about the protocol or the schema or anything like that. We are just focusing on the framework and the toolkit. So we can use the toolkit to collect, transform, and ship observability data that might or might not originate from OTel instrumentation. And I think this is the part where most of the confusion is coming from, because the telemetry data might or might not originate from OpenTelemetry instrumentation, but you can still use OpenTelemetry, in this case, the toolkit, the collector, the operator, to collect, transform, and ship that data to somewhere. And people might not realize this early enough, that you can you don't have to instrument your application with the OTel libraries, for example, and SDKs, if you want to use the OTel collector, for example. I think that was my last slide. That was about what OpenTelemetry is. And then we can move to a different kind of presentation. We just started to take a look at this presentation mode in Express just before we started the session, and we found it quite nice. So I will use this for a few slides. So I think this diagram is nice in a way that it shows that both OpenTelemetry libraries and SDKs, if you are only focusing on the framework and the toolkit that we were just discussing, and the OpenTelemetry collector and operator, that these are both called OTel or OpenTelemetry, but these are not the same. And I think this is the part that confuses people most of the time.
So I can have, let's say if I focus on the libraries and SDK, so let's say I write my application in Go, whatever, it doesn't matter.
Mm-hmm.
I can use some SDKs or some OTel libraries to instrument my application, right? To emit some metrics, right?
Or logs or traces, but yeah, any kind of telemetry data. Everything is.
Okay. So I can use a library that allows me to like instrument my application to emit some data, right? Some telemetry.
Yeah, exactly.
And then on the right side with the collectors and operators, I can then scrape, I don't know if that's the right word, scrape that data or ingest that data or collect that data from the applications that were instrumented with OTel libraries or without OTel libraries as well, right?
Exactly. I have another diagram for that. So you can either use OTel libraries SDKs to emit telemetry, or it's also a valid pattern that you have existing instrumentation in your applications, but those are not coming from OpenTelemetry libraries. Those are coming from I don't know where. You can use for metrics, for example, you can use the Prometheus Go client libraries. Mm-hmm. For tracing, you can use Jaeger. For logs, you can use whatever you want to use. So there are lots of ways. But both of these, any kind of libraries can expose some kind of telemetry data. And at the next stage, you can use OTel. And this OTel here is the OpenTelemetry collector or operator. The operator is like a regular Kubernetes operator. So it's basically just an operator pattern deployment of the OpenTelemetry collector itself. But these are the actual components that you can deploy in a Kubernetes cluster, for example. Mm-hmm. And regardless of where this telemetry data is coming from, you can use the collector to collect them, transform them, and ship them to any kind of backend that is compatible with OpenTelemetry, basically.
Okay, so basically the OTel libraries, if I use one of the OTel libraries, what I get is I'm assuming standardized way of exposing the data or exposing the telemetry. Is that the right way to put it? Is that what the OTel libraries give me?
Yeah, exactly. So in the open source, we can approach this from two different angles, and one of them is that you are only using open source tooling. In that case, before OpenTelemetry arrived, you were most probably using the aforementioned Prometheus libraries to instrument the application with metrics. You were using Jaeger libraries and SDKs to add tracing, and that was fine. And that's a trivial use case. You have the OpenTelemetry, the OTel versions of these. It's a single library that you can use for everything. So there are some shortcomings there, and it might be used to use the libraries that prove to be production ready already. The tools that were created for that single job that they were created for So there are some differences what kind of libraries you are using. But the interesting part is that if you are using, for example, a commercial observability backend, for example, I don't know, New Relic, Datadog, Splunk, or any kind of monitoring tool. And if you want to ingest metrics there, and you don't have, for example, if you have a service mesh like Istio, then that's easy because Istio will take care of generating logs and metrics for you. For traces, it can also help. The job is not done just by adding Istio, but it will make it easier to introduce tracing, for example. But if you don't have this kind of help and you just want to add metrics to New Relic, you have to use their libraries and their SDKs. And then you can have some challenges. It's not extremely frequent that people are changing from one SaaS observability backend to another, but it can happen. I don't know. There can be a company who will buy the other company that you are using. Splunk will also acquire it. And these changes, or it can just can get extremely expensive. Datadog is expensive. Splunk is also expensive. So it might make sense to look into whether it makes sense to use a different kind of tool as a backend, as a SaaS product, for example. But in that case, you have to recreate all of the custom instrumentation that you added with the commercialized proprietary SDKs and libraries that were vendor specific to your previous vendor. And this is one of the, if we are talking about the SDKs and libraries, this is one of the promise of the OTel libraries to make this transition seamless, because everything is instrumented with this open standard, and you just basically change the configuration in the OpenTelemetry collector to configure another backend where you are pushing just everything, and everything should work. There can be differences because the actual vendors also have to be compliant with the schema, with the protocol and everything, and there can be certain limitations. If you're talking about metrics, there can be limitations in the number of, I don't know, labels they want to ingest. So there can be some subtle differences, but in general, it provides a portability to your telemetry pipelines if everything works fine. And you couldn't really do that with the proprietary libraries. You have to redo everything, and changing and migrating if someone is still using those, very expensive.
Yeah. So Dennis mentioned OTLP protocol, OpenTelemetry protocol, right? I think that's what. Okay.
Yeah, OTLP protocol. That's also a protocol. If you are pushing all this data into a SaaS backend, then most probably you are using OTLP as the protocol to push that data. So you have an OTLP endpoint for your vendor. That's usually a gRPC endpoint and an API key that will identify your user. You might also have to configure the actual tenant if you have. If the vendor has those kind of capabilities, but generally that's an ingestion point for custom commercial backends. But for example, that can be used for open source tooling as well. In the actual demo, we will take a look at how you can push logs and traces with OTLP, for example. So that's not necessarily only a solution for the commercialized backends, but OTLP can transfer over metrics, logs, and traces.
Okay. So basically, regardless if it's OTel library, non-OTel library, your applications use that, expose the data, you gather. That data is collected by the
collector.
By the collector, by the operator, right? Is that the name? The operator. It's collected.
Or operator.
And then it can be transformed or whatever, and then by ship it gets pushed to some compatible backend using OTLP protocol.
Yes. One important thing is that it's not necessarily a push. The exporter, the collector can also just expose this data that is being collected by the by the collector.
Oh, and then the backend itself can like scrape and pull.
Exactly. So for example, if you are using the Prometheus receiver, then you are basically just adding a scrape config that is extremely similar to what Prometheus also has. There are some very minor differences, but you have very similar scrape config. And after that, it will, by default, just expose that telemetry data if you are using the Prometheus exporter. So you have a port for on your collector, and if you have a Prometheus, you can just scrape that port to get the metrics, if that's an architecture pattern that is interesting for you.
Yeah. Okay. So the OTel compatible backends would be, in this case, commercial stuff, right?
Yes.
Or things like Prometheus.
Prometheus, yeah, and any logging and tracing backend that is compatible with this format. So Jaeger, Grafana Labs, Tempo, Loki. You can use anything basically. Nowadays is really a popular choice. So every vendor and project has support for OpenTelemetry.
Okay. So the backends are not necessarily part of the OpenTelemetry umbrella. They're like all these separate applications that you can have, and then this middle part, the collect, transform, ship, this operator, this is one part of the OpenTelemetry, right, that you like run inside your cluster, right, that acts like a mediator between like getting your data and then either exposing it for a compatible backend or pushing it or shipping it to something, right?
Exactly.
Perfect. Okay.
But I think this is a really nice picture because it just shows that you don't have to use OTel libraries necessarily to be able to use OTel collector or an OTel backend. You can just, if you have this in the middle, then you are fine.
Yeah. Oh, okay. So theoretically, if I have, let's say I have my applications running, I'm not using any OTel libraries. I don't have to go and retrofit my applications to use the OTel libraries. I can instead configure the collect, transform, ship portion to transform the data in a format that's compatible with the backend. Does that make sense?
Yeah, but most of the time you don't really. So this transform is most of the time not a transformation to make that data. I mean, yeah, of course you have to expose that, and if you are pushing that through OTLP, the protocol, then you have to be compatible with the protocol and the schema and everything. But this transformation can also include, I don't know, if you're talking about metrics, then you can just get rid of high cardinality labels or labels that you don't need. You can add custom fields to your log messages. You can get rid of certain spans in your traces that you collected. So you can do lots of things there. You can enrich the metrics with additional metadata, for example. So there are. It's really
okay. So the transform here is not necessarily the make the data so it fits some specification. It's more of a enrich the data, clean up the data, enrich the data.
Yeah,
cetera,
exactly,
right?
exactly. There are lots of different processors that you can use. You can yeah, as you said, you can just extend the data and enrich it with additional metadata. There are some processors that are there to make this pipeline more reliable. So, for example, you can use things like memory limiter or batch processor to make sure that the shape of the data, the characteristics of the data, is reliable to be transferred to the actual backend at the very end. So, there are lots of. I will show some examples later on what kind of tooling we have access inside the ecosystem.
Yeah, so Dennis is saying, so OTLP is one of the listener's incoming endpoints for the OTel collector. And the collector accepts Jaeger, Zipkin, native OTLP. Then exporters export in vendor's format. And then if you're exporting to Jaeger, Prometheus, Datadog, of course, you're not doing it using OTLP, but their native protocol, whatever they're using, right? And this is a benefit of OTel pipelines. It helps you to translate protocols. For example, Zipkin is then translated and injected into Jaeger.
Yeah, but Zipkin is also already quite conformant with Jaeger itself, and depending on what kind of so there are multiple categories here as well, because we will take a look at a few exporters, but there are some cases when the actual exporter that you are using can be vendor specific. But what I see is that the vendors are moving into just having an OTLP endpoint, and they will handle the rest at their backend side. And in that case, you don't have a vendor specific. You don't. Let me think. What could be a good example? For example, for Datadog, you have an actual exporter, and you have to configure that. I think, if I remember correctly. But for example, for Lightstep or Honeycomb, I think you only have an OTLP endpoint, and they will take care of the rest. So if you don't necessarily find a vendor-specific exporter, then you have to consult with the docs on the vendor side, because it might not even be required. You can just use OTLP and push everything there.
Dennis saying everyone is adopting OTLP. Jaeger added it. Yeah, so it looks like people, like, it's converging on this spec, right? Or
yes, exactly. Even Prometheus added it just recently.
Okay.
And that was quite, Prometheus already had a push ingestion mode. That was if you do remote write, but remote write isn't OTLP. But that's another way to push metrics. If you don't want to use the polling method, that is scraping. Yeah, so it basically looks something like this. If you want to take a look at an actual configuration, then it can look something like this. I think this is a fairly similar config that I have running in the cluster, and we will take a look at the cluster very soon. But basically here we have, that's basically the config map for the collector. And here we have a receiver section where you specify that, okay, I want to listen on this port for all the hosts, and that's my OTLP receiver endpoint. Then you can have the processors. As I mentioned, there are some that are specific to the reliability of the pipeline. So patching and memory limiter are ones that should be added to make sure that the data that you are forwarding is badged properly, and you are not getting out of memory exceptions. And then here we start to move into the additional enrichment kind of capabilities. So for example, you can add some additional attributes to logs, for example, that are mesh specific in this case. And these are not necessarily required. These are just here basically in this very case to be able to correlate logs and traces out of the box with these config options in a Grafana stack, for example. But there are lots of different processors that one could add. Then at the very end, you have the exporters. In this case, I have a Loki endpoint. Loki is running in my cluster. You just specify the service, the port, and the actual API endpoint where you want to push. And here you can see that I have also an OTLP exporter, but this, in my case, will point to tempo.
Okay.
And after you specified all these pieces here, these are just laying around, you have the pipelines. And you specify that what kind of metrics pipeline, logs pipeline, and trace pipeline you want to use. And you just list the things. For example, for logs, I want to receive all my logs on OTLP. So that's this, basically. So everything will push the logs to this port, and this pipeline will listen to those events and receive them. Then you apply the processors, and finally you push the Loki.
Okay, so the receiver, so that receiver part, the 0004317, so are the applications configured to push the data to that endpoint, or how does the data get?
Exactly. In this case, yes. So this is the Istio setup that I have running here, and here Istio will be configured with this endpoint to push the logs there. I will show this.
Okay, so this is the receivers are where does the collector listen for for
Exactly.
for the input. Okay, and then the pipelines are basically saying for your logs, listen on the OTLP, right? And then here's the list, the ordered list in which to process the incoming logs, right? In this case, right?
Exactly. It might not be the best. I made a bad job with ordering these processors, but yeah, this is actually
Okay.
an ordered list. And
Okay, so should be whatever, like do this first, then do that, then okay.
exactly.
And then the resource slash mesh and the attribute slash mesh, those are not like those are the fields that you came up with, the names, or is
yeah,
this
so
like okay?
that's an excellent question, and this was the part that was the most confusing in the early days of OpenTelemetry, because it was absolutely not clear how you should name these, and are these reserved names that you cannot use, or you
Yeah.
have to use these, or what is it? But basically, you you have the category here. So you have the resource category here for, or let's try to take a look at another example. I might not have a better example in this very case, but I will show another one when we take a look at the cluster. So you have this first part. This is the category. So I want to use the attributes processor. That's a reserved name that is specifying the actual processor. But after the slash, you can name it
It's your
whatever,
stuff, whatever
exactly,
you want.
whatever you want. You just have to make sure that you are reusing these later on in your pipelines.
Okay, and then the resource and attributes is just saying it's like different pieces of where to add stuff to, I guess, if I
Exactly. So under processors, you have yeah, exactly. These are not named properly. These are this is I will, yeah, I can show you some
yeah, but
practical.
it's fine. But it's basically
it-
it's the first part is reserved, right?
the
And
first
it's
part is reserved, and second part is up to you, and you
whatever
can
you,
name
however you name it. Yeah. You called it
exactly.
mesh because we have a mesh, and then the resource slash mesh is just saying insert a key with name
Yeah. So
Loki dot
here,
format, right? Or Loki
exactly. So
resource labels.
this is Kubernetes specific. So what I'm doing here is that I'm adding into the actual log lines the namespace and the instance as labels, because
Okay.
I will be using these later on to correlate logs and traces. It will
And
make
then
sense.
yeah,
It
and
will
then
make sense later on.
yeah, but these the Loki dot resource dot labels, this is it's related to where the data will, or where the logs will end up in, or where the values will. It doesn't say what my application, it's not like my application is gonna do like Loki dot format for something,
Yeah,
right?
exactly. Your application has nothing to do with this, and it doesn't have to be application aware, and the application also doesn't need to be aware of what kind of pipeline you want to use, or what kind of telemetry tooling you want to use. You can have access to this.
Okay. And then Istio underscore client underscore type, is this something that Istio D exposes? The name?
That's Istio specific.
Okay.
I just realized that I use all the, if this is a 101 session, none of this should be,
No,
should be used.
that's fine,
There
but no, but it's useful, right? It's useful to, like, at least for me to understand what, like,
yeah, so yeah. But these are all excellent questions, and these are questions that people should be asking, and these are not the ones that someone should be using to explain everything.
But basically the key names, right? The key names that you use there, Loki dot format, Loki resource dot labels, Loki attributes dot labels, those are specific to that exporter, right? So if I
to the processor.
But it's because you're okay, to the processor.
See, I made a really bad job about putting
no. It's as I said, like, I have zero knowledge about this. Maybe let's
it's if you have knowledge, it will be still hard, because these processors are are not trivial to put together. I will show you what kind of documentation you can use for this and what you should use for this, and that will make it clear.
Okay.
But yeah, basically here that's basically the actual config map for the collector, and here I have this nicer visualization.
Okay. So this one actually shows the.
It's a bit better. It's a bit better. You have the application. If you are running Istio, you have the proxy. Then you are just powering these receivers for metrics, logs, traces. Then you have this in the pipeline. This, by the way, is the OpenTelemetry collector that's running. And here I have some examples for each stage in the pipeline, basically. And at the end, it goes off to wherever it should
wherever you wanna, read it from. Okay, so well, let's look at the demo because I'm curious how it.
Yeah, we will take a look at the demo. Just before that, I will show this GitHub repository. So if you go to OpenTelemetry collector contrib, the contrib is important because everything that is not core OpenTelemetry that goes into this contrib repo. And here, basically, you have all the Lego pieces. So if you take a look at the folder, let me try to make this bigger. So here in this repo, you have exporters, processors, and receivers. So these are basically where you can cherry pick the ones that are good for your use case. For example, you can go to receiver. You go to receiver, and you see all this kind of stuff. This is everything that OpenTelemetry, the collector, can ingest. There are some vendor-specific stuff here. There are some technology-specific stuff. For example, you can see SQL, SQL receiver, SQL Server receiver, SQL query receiver, Splunk AGC receiver. So this is vendor-specific in this case. Then you have, I don't know, some easier example, Prometheus receiver, for example. If you just want to scrape metrics, then you can use this. And this is the documentation that you should take a look at. Everything in the GitHub repository it's not necessarily always up to date, but that's the best you can get. You just don't go to the official docs website because that might not be.
Oh, you might not like up to date. Or...
Yeah, it's not always up to date. Everyone is mostly just updating these README files for the specific receiver processor exporter. It's easier to just use this and take a look at the config or even the code, because if you, for example, take a look at the actual code for this, you will see that these are quite short and easy to understand. So it's not extremely hard to find bugs or see how everything works together. This sounds like a terrible advice. If you want to understand what happens, you just have to check the source code because it's open source. This documentation is also quite good, and there are some practical examples here about how to configure this. What are the limitations? What is experimental? Another example here. There's also you can also check the test cases to see how everything works.
Yeah, maybe.
Exactly.
Yeah.
So this is where someone should go and look for pieces. For example, if you go to the exporter, you will see where you can push the telemetry data. You can push to, I don't know, AWS CloudWatch log, for example. Some Azure specific stuff is here.
Oh, let's. I'm looking. Click the Loki one. Loki is the one that you had that in the example, right? And that's where it would answer my question that I had, right? Is like it shows the actions, right? The insert, and then what is the key name, right?
Exactly. So this is if we approach this from after we take a look at this documentation, it might be easier. So here you can see how the conversation happens and what kind of actions you have access to here and how you should configure things.
Okay. Now these make sense because when you look at the configuration, it looks like for me, it's like I have no idea what those values are or what they're coming from, but it's basically it depends on what your
what is the actual
what your actual exporter is, what are the like processors and receivers that you're using or whatever, and you configure it based on that.
Exactly. If you take a look at the processors, for example, and we go to resource processor, that was the one that I used, I think, you will see documentation for that. No, I think it was attributes processor. And you have a list of all the actions that you can take in the configuration. These are quite nicely documented now, so you can. People, I was working with people who were completely new to OpenTelemetry, and they were able to achieve things just by checking these README files. So that's nice. Back in the days, you were not able to do that. It was extremely hard. So everything is quite nicely documented here. Here you have a nice section like this, but it would be even better if one of them would be decommissioned, or there would be only a single one. But this is really bleeding edge stuff. So there are some cases where you have multiple possible solutions to achieve something, and one of them is better, but you might not sure which is the better if you are coming from no background in OpenTelemetry and you just try things out, and sometimes it works, sometimes it's not. You will see the issues. You will just see for yourself how it works, and you might switch to another one if the one that you started with doesn't work the way it wants to. But yeah, this is what I recommend for documentation, because this is quite nice. So I think we can take a look at the actual demo. I have some files here, but basically what I have is ham file, which is basically just. Are you familiar with ham file?
Yeah, I am. It's just a templatized way to deploy stuff, right?
Yeah, exactly. I really like it. It's if you need to install lots of ham charts and you need to maintain some kind of ordering between them, or you just don't want to install multiple ham charts right after each other, it's quite nice to just list all of them in a single file and do something like ham file sync, and it will just apply all of them. I really like it. I use it in all of my home projects. So what we have here is that we have Istio. For Istio, you need three ham charts. Istio base for the CRDs, Istio discovery, Istio D for the control plane itself. And if you take a look at this, we will see that
this is the actual extra configuration here that needs to be done in Istio, right?
Exactly. So this is like the mesh config, and here I specified two. So I have the access log file, so I'm logging everything to std out. But at the same time, I also have this extension provider here. And here you can specify an OpenTelemetry access logging service. I call this OpenTelemetry logging. You just point it to a service, which is an OpenTelemetry collector in this very case. You specify the port and the format. So here you can see the labels that you are listing. So for example, you were asking about the Istio client.
Okay,
right?
yeah. There you go. Okay, I get it now. Okay. So this is where you do the mapping and you say, hey, here's like Istio client type. That's the actual, I guess, the name that you're going to use, right?
Yeah, for example, you can use this to identify where this log entry is coming from. In this case, it's coming from the Envoy OTel ILS that is configured here. But this can be, I don't know, it might be easier to name this OpenTelemetry logging. But that's
and then so the access log format that you're specifying above, right, line 36, that's just for what you want Envoy to log out, right?
Yeah, that's for std out. So this actually in Istio provides a really nice way to push logs, so you don't have to use the file log receiver necessarily, because file log receiver is where you are tailing the logs from the actual host where your stuff is running, but that expects you to give more permission to the collector, because it has to be able to read the logs from where the logs on your actual file system are.
Yeah.
So this is actually a better way to.
And then the log format. So that's the log format for. How is the log format on line 45 related to the access log format on 37, line 37, or are they not related at all?
They are not related. They are, in this very case, they might be extremely close to each other. They might be even similar. They might be even the same. I'm not sure. But basically, the good thing is that you can, it's a pretty frequent use case when you want to have some sort of logging format for your std out logs because you want to troubleshoot something quickly. But let's say your security team in your organization needs some additional metadata, and that to be ingested into Splunk, for example. In that case, you can use another format. You can point that to your OpenTelemetry collector. If you even want to do more transformation on those log entries, you can do that as well, and you can just ship everything to OpenTelemetry. But for example, to Splunk at the very end. But it's a pretty frequent use case that the ops people or different people or the developers need some kind of other access log format, and they can use std out, or even they can add additional providers here and specify different logging based on the actual need of that particular team.
Yeah. So basically, access log, if I translate to like practical terms in my mind, access log format is something that I'll see the logs in when I do kubectl get logs pod c istio proxy, and then line 44, that log format is something that I'll see in Loki.
In Loki, exactly.
Where it's gonna end up.
Exactly.
Right.
Exactly.
Okay. And then also this allows you the labels that you have there, right? They allow you to map additional things, right?
Yeah,
on top of those logs, you can say, hey, these are the labels, and then use, I remember that's the envoy notation, right? To get out the extract the values, I guess, from the entries. Yeah.
And if you want to do correlation, if you remember, I had these additional tags added in the pipeline for logs, and these are needed because I'm getting the pod name from the environment variable and add that as an instance label, because in Prometheus an instance is your pod basically. So I have to populate the value of this and the namespace, because this is what will be used behind the scenes to craft the actual queries that will match for your logs at the very end. I will show this very soon, but you can. This is the way to add additional metadata, for example, or any other custom.
Yeah, so I can basically, by adding this later on, I can do queries on X forwarded client cert if I want to.
Exactly. That's That's a really use case. And then you can just specify another provider for tracing as well. So let's say you also want to push traces. So you add another one, OpenTelemetry tracing. You specify the very same endpoint because you will push to OpenTelemetry collector again, because that's your centralized collector. At scale and in production, you might want to use a dedicated sets of collectors for all the signal categories. So a dedicated sets of daemon sets for logs, and another set for metrics, and the third one for traces, because you don't really want in production and at scale your tracing pipeline to interfere with your metrics pipeline, because you might be alerting on metrics and you don't want to
like latency and whatever you want to.
Exactly. You have lots of trace spans generated because of some bug. You don't want your metrics to go down because of that, or ingest everything to the backend. So this is the config that we have. Apart from this, I have an Ingress gateway deployed here. I have the OpenTelemetry collector. I have Grafana tempo, Loki. The actual values are not inline for this because it's not that exciting. Everything is just fairly demo values, let's say. For Loki, I'm not using demo values because I'm also running Loki under my blog. So these are, I consider my settings production ready because I'm using those under my blog. But apart from that, these are not really relevant now. I also have Prometheus stack. And metrics is interesting because I'm scraping metrics, but those are not. So let's take a look at kubeprometheus stack. In kubeprometheus stack, I have this dirty config here to scrape XTOD and the envoy stats config. But this is a good example because you can consider this a metrics instrumentation that is not originating from OpenTelemetry libraries. So these are added by Istio. So I have Booking4 running there. Those doesn't have any metrics, or at least I'm not using those. And Istio adds these additional metrics. So no OpenTelemetry up until this point, but the OpenTelemetry collector could have a very similar scrape config like this. That's the Prometheus receiver that I mentioned. And that way, the collector could scrape the data and forward and expose that or forward that to a Prometheus instance. But if you take a look at the actual OpenTelemetry collector config here, if you go to pipelines, then we see that metrics is null. So I'm not using that. For metrics, I'm just using the Prometheus scrape config that I just showed to you. And for logs, I have this OTLP receiver. I am doing some basic processing, then pushing everything to log key. And for traces, it's quite simple. I'm listening on the OTLP port and exporting to the other OTLP port. It can be confusing that the names are similar, but this is an OTLP receiver and that's an OTLP exporter. So this is why
it's gonna, you can use the same name, but it's gonna look under a different key, right?
Exactly. That's correct. But let's say you want to do something like in your dev environment, you want to forward everything to Tempo. So in that case, you do something like this. Let's say this is the dev config. And what you can do is that you can just copy paste this part, have another pipeline. You can call this prod, and you can do something like add a new OTLP exporter. And this new exporter is OTLP / I don't know, Datadog.
Whatever, yeah.
And this is Tempo. So what you can do later on in your pipeline is that you can specify for dev, you want to forward everything to Tempo because you don't want to pay for Datadog in your dev cluster, which is totally reasonable. Not everyone has that kind of money. And you can, in production, use Datadog. So here, this example shows that this part is reserved. This is the actual category that will identify the family of the exporter or processor that you are using. And after that, you can use whatever you want. And in this case, you can just specify. And the same aligns for pipelines as well. So you can do something like traces/dev or traces/pod. This might be traces dev, traces Datadog. This might seem more like a actual practical example from the real world. Yeah, so you can have some configuration like this. Everything is synced out already. And I also have some Istio dashboards here at this Helm chart. So after this, we can send some requests to product page. That's the front end of the Booking4 example that is running here. It should give us some replies. We can even do something like, I don't know, take a look at where it is running. I have this here. Product page. This is the actual front end. Sorry about that. Product page. So this will load the website. That's a proof that I have something running here. That's the website, but it's not that exciting. So what we can do now is that we can port forward Grafana. This is Grafana that I also have running locally. And we can take a look at metrics. So just as usual, you can do something like Istio request total. These are not coming from any OpenTelemetry tooling. This is basically just, for example, you can take a look at what kind of destination app you might have. In this case, it's product page. And you see that, okay, I had some requests. This is metrics. So let's say, let's take a look at these. What kind of, what's the difference between the two? You can do something like sum, where you can sum all of this by response code, for example. Oh yes, this was yeah, that's a difference. So we can try to see the logs and traces for this request. So for that, we can just split this. We can go to Loki and see these are the ones that we configured. Istio client type, and we have Envoy OTel IRS. And if you just search for this, you will get all the logs. And here, if you search for 302, then you will find the actual request. That was the request that we had. And if you click on that, you will have the trace ID here. And after that, you can just click tempo and go to the actual trace and see, okay, what happened? When did this request spend the most time? Where is the bottleneck in my code? These kind of things.
Nice. And this, so we went from, what was the previous window that we were at before we went? Was that tempo as well, or?
No, actually, no, that was
Loki, right? Oh, okay. So Loki was the labels, and then this is where we would see in the attributes. This is where we could see all those extra attributes that we added, right, as well.
In this case, these are not added as fields, but that would be possible to add those, all of those as fields if someone wants to filter based on that. Yeah.
Oh, okay. And this then automatically correlates the logs with like tempo to look at the traces, right?
Yeah, almost. It's not.
Almost.
I wouldn't call it. I can show it to you what's happening behind the scenes. We can check the data source, and if you go to tempo, then we will see what's happened.
There's a query, right?
So this will, no magic is here. It will just basically, you specify a look back and look ahead time to where to search for logs. And this is the query. You are searching for this exporter here, and you basically match to the instance that is the pod. So that's likely
the one. It's not exactly the one, but it's going to be likely the one.
Yeah, you can fine tune this. You can add additional metadata as tags to make this more robust and make it proper correlation. But yeah, this is what you can do here now.
Nice. So you basically get the whole. I can see the requests, and then I can look at the logs, and then I can correlate my logs. Like you can imagine having like a 404 or 502 or 500 or whatever, right? Some error.
Yeah, we can even do that. So let's try to call product page 2. We don't have that.
Yeah.
So if you check the response for this should be a 404.
Yep.
Here it is, 404. So after I have this, I can go back to Grafana. And first, let's take a look at the actual logs metrics. So Istio request total.
Yeah, and in the actual like production, you would have like a dashboard set up where you could see the right away anyway.
Surely I have that already. So if you go to Istio service, these are the upstream,
the built-in, the
built-in ones, exactly. Yeah. So if you search for, depending on the scrape time, it will take some time to show up. But I should. Well, actually, I won't have this here because it's not.
It wasn't. There's unknown, but I don't know.
Exactly. So it's easier to go just to Istio request total.
Yeah, but theoretically, you would set up some sort of a dashboard where you could see these failures, right?
Yeah, that's correct.
Yeah.
So if we search for this, whoa, I'm doing crazy stuff here. Great. Then specify that we are interested in a response code that was, let's say, 5 something.
Extra quote.
Yes, that's right. Thanks. So here we see that that's our request, and we can even see this from the logs side. So if you search for your logs and search for the actual 404, then you get this one.
Yeah.
NR root not found. That's our request.
Yeah.
And you can even see this from Tempo side. If you just search for the most recent request, you will see that the duration is missing from some places because that request didn't really go anywhere. If you click there, you will see that, okay, this was most probably a 404. You have all the attributes here as well in for tracing. So this is quite nice level of insight.
But basically you have all the data that you need, right? All the in one place in a way, and then all of these, like, you can always go and create your own dashboards here in Grafana, right? You can modify the UI, so as you click on the things, it will take you automatically to Loki, to Tempo, whatever you want. It's just a matter of how much because realistically in like production, people probably won't, you would already have these things created. You wouldn't be like filtering for 403s. Maybe you would have like a whole thing already set up, like a dashboard.
Yes, there are. Most of the time people have their own sets of default dashboards, but if you are trying to get into the actual root cause of an outage that you might not have the dashboard for everything, and you want to correlate everything with everything else. And in that case, I really like this Explore tab, where you can just visualize ad hoc queries, see if okay, I had this here. For example, you could, okay, I had a 404 here, but is it the same
same one, or it was
that I had in the logs? And you can see that, okay, these are roughly at the same time, so probably these are connected.
So it syncs up the times.
Exactly. So it's very, very nice to correlate things manually like this. You cannot correlate everything. There are some, I don't know, failures that are lingering in your system and might only result in an actual symptom later on. But most of the time, this is like a superpower to be able to see, okay, these happened at the same time. So they probably are related, not necessarily, but there are some cases.
Yeah. Awesome. Well, if anyone is still listening, if there are any questions, like I've personally learned a lot from this. Coming from like zero knowledge on this, at least I know where I could go and get started with this.
You know where the documentation is. You see what you can achieve at the very end if you have a setup like this.
Yeah, and it's pretty much like the like installing Istio, all that Helm file that you had. That's more or less, it was just, there wasn't a lot of customizations there, right? Like,
exactly.
Not like
we specified 2 extra providers to format the logs and ship the traces into OpenTelemetry. And even the OpenTelemetry part that also wasn't too complex.
Yeah. Awesome. Well, thank you very much, Krisztian. I hope people find value in this. I definitely did. And then we'll be back in a couple of weeks, I think, with another episode. I don't know what the theme will be, but if anyone has any wishes, let us know. But until then, enjoy, and we'll see you next time. And thanks again, Krisztian.
Thank you for having me.
Bye.
Bye, everyone.